Think of a large language model like a brilliant brain trapped in a jar. It holds a vast amount of knowledge and understands complex text, but on its own, it cannot actually take action in the real world. To turn this passive intelligence into an active agent, we will write a custom Python script from scratch. We are bypassing complex frameworks so you can see exactly how the mechanics work at a low level. To execute this project, you need 3 things: basic knowledge of Python, a local code editor, and an API key from OpenAI or Gemini. Stripping away external libraries reveals the underlying logic. You will see that AI agents operate through a series of structured, predictable steps. Step 1. Before writing code, we must establish the conceptual anatomy of an agent. An autonomous system requires a specific structural foundation to operate reliably. This diagram maps 4 agent pillars. First, the brain, your core LLM processing engine. Second, tools, functions the LLM triggers, like scripts or searchers. Third, memory, short-term recall and long-term vector databases. Fourth, planning, using React methodology to reason and act. Integrating these 4 components transforms the static text generator into an autonomous problem solver. With the architecture clear, we move to the coding environment to build the tools pillar. We start by defining a mock Python function called getWeather. For this walkthrough, it returns a hard-coded string indicating clear skies in a specific city. When building these tools, we isolate the agent from critical system files. We want to prevent the model from accidentally overwriting data or entering an infinite loop of file creation. With the tool defined, we move to the planning pillar. We must write a restrictive system prompt controlling how the LLM uses this function. The model must be explicitly ordered to output its decision in a strict JSON format. This ensures the computer can read the decision as data rather than just text. If the model includes conversational filler, such as, "Sure, I can help," before the JSON block, your Python parsing code will fail. A standard script requires clean, structured data to work. It cannot interpret the model's intention if the command is buried inside a paragraph. Prompt engineering serves to produce reliable, API-like responses that our script can process automatically. Step 3 is building the control loop. This acts as the bridge between the LLM's text output and our Python environment. First, the loop sends the user's query through the API to the model and receives the JSON output. We then write a simple if-then statement in Python. If the JSON action matches our toolname, the script triggers the getWeather function. In the final phase of the loop, the script captures the output from the Python function and sends it back to the LLM as a new piece of information. The model now has the raw data it needs. It processes that data to formulate a final, human-friendly response for the user. This reveals that agent autonomy is the result of standard conditional logic interpreting structured text. Let's execute the completed script in the terminal to see it in action. We provide a test query. What should I wear outside in Seattle? This requires the agent to retrieve data and reason about the results. The terminal output shows the raw JSON generated. Our system parses that data, lends the weather tool, and hands the results back to the brain. The final output provides the current weather and a logical suggestion to wear a raincoat, completing the task successfully. By integrating the brain, tools, and planning pillars, we have successfully established a loop of autonomy. Understanding this manual loop provides the groundwork for adopting frameworks like LangChain, which simplify the process of building agents that can read thousands of local files or search the web.